Hi, everybody. This is the Working Group Device Management meeting on native resources in DRA on April 7th, 2026. I think we have one topic on the agenda, which is from Francesco. So I'll hand it over to you.
Thank you. Now I'm trying to see how I can share my screen, and hopefully I managed to.
Yes.
So, um, so we recently, the context is that we recently hit the first milestone for the DRA CPU driver, thanks to the effort of Praveen, and which worked during the KubeCon week to make it happen, and the other contributors, which we have already a couple of new contributors, which is great. So we were discussing the next steps, and I raised this topic because I feel that now is the time to bring up this discussion because it will, if we decide to implement changes, that will cause the less disruption to the users, which are or the early adopters. I won't expect we to reach a conclusion just yet, but I want to kickstart the conversation. And the conversation is about should we, the TLDR, the spoiler is, should we split the DRA CPU driver or should we keep all in one? Why? Why this idea? Because right now, the code we have exposes two fundamentally diverging modes. One is the individual mode. So each and every CPU core is presented as its own device. And this is great for integrating external shadowware, and we care a lot about, for example, SLARM. This is one of the premier use cases for the driver right now, so it's important. And at the same time, we have also another mode, for, the group mode, which exposes. It's more similar with all the many do difference with the GPU use cases. So we have a bunch of cores, and basically you don't need to pinpoint the exact core you want. So you ask for CPU resources, and those are taken by the available pools. So this is actually, in my opinion, this is really me speaking now. This is a bit more aligned to the resource model, but it's debatable. What is much less debatable is that we have two different modes in one driver. So it's not that, we have an extension of a mode and the other is similar and has some flavor. They're really quite different. So, and that was there's a function of how the driver was evolved. So it grown up out of necessity from the current state. That's fine. I mean, it is part of the early stages. But again, I believe that now is the time to ask this question because later, which will be much more awkward to solve. So if one wants to asks me, okay, which one is the best mode? Because no, okay, those are two different. Which one's the best mode? And the answer start with oh, it depends, which is a fine answer, but tells us that there's a tension underneath. So okay, you need that if you need that. So it's a decision point right at the beginning, the very first step you think you set because the current default is grouped mode because, for example, we believe it scales better with the many core CPUs that are in the market actually, or are about to hit the market. But at the same time, if you want to use its best and strongest use case, you have to set individual mode. So we have already two resource model to quite different operational mode. And then we throw in the mix the memory support, which is something we want. There is because there is a growing consensus in the community that a combined driver is the best approach. So we are talking about renaming the project, and this is another, contributing factor to the general thought. Okay, maybe we should split, maybe not. Maybe the best approach is keep everything as is and just merge memory support, or not. But those are all the things that causes this question to rise quite naturally, I believe. So integrating memory will call for a project scope change, repo rename, infrastructure rename, and so the question would be, okay, we keep merging stuff, or is it the time to split? And compounding to that, we also have another important factor, which is the individual mode is pretty much done in the sense that, okay, we know what we need to do. At the best of our knowledge, we are there. We need fixes, we need improvements, we need optimizations, but feature-wise, that's basically it. While on the grouped mode, we want to use many new hot DRA features which are in the pipeline. Like, for example, we need the consolidation of partitionable device. We need the stabilization of, GA level of the other features. So it's hard, for example, to say it is GA. We can say, okay, we focus individual mode, we polish, and then becomes GA, and then we add another different model with its own set of challenges on top, which is, we can argue, okay, yes, but the individual mode, maybe except maybe bugs in the shared parts, is not going to be affected. At the same time, yes, but we are doing something, which is different. So it's an harder call than it probably should be to call GA. So we have this timeline tension. So a possible way to move forward is we keep the current driver as is, and we focus on the individual mode. We keep adding fixes, we keep adding optimization, but we basically downscope or say, okay, that's it. This driver is for individual mode only. And then we start a new side project, which is, okay, we have we focus only on the grouped mode in the new driver, and we merge the memory support, which is, by the way, is much more naturally lending to the grouped mode, because you cannot target that individual memory page at the individual address or this specific huge page. So this way, I believe we have a clearer focus. You still have the fundamental tension of having two kind of overlapping driver. But I believe that use case justification and the projected, consumers, they justify the split. It is at least something we can discuss. And the other driver would need to re-implement the CI and its all the infrastructure logic, but if we merge memory support, it will have its own set of disruptions. So it's not, some bunch of work which we can otherwise skip. So that's it. That's the idea I want to pitch, and this is what I seek for feedback from the community, starting from this working group, and then depending on the feedback on other larger communities.
Okay. Yeah, actually, this makes a lot of sense to me. One minor comment: I don't think we're going to have a Kubernetes DRA org. We're just going to use K-SIGs that we kind of got pushed back on by the GitHub folks. So, but we'll have a library. We'll have some repo for library code or something. But that's a minor point. Separate them, I think, to me makes a lot of sense. Praveen did give me a preview of this yesterday, so I was aware of what you were proposing. But I'm actually thinking about, so the main advantage of individual mode is the ability to address individual cores. And I'm sort of wondering if we can put on the roadmap. We keep seeing this recurring pattern across different different types of resources, where you sort of have a template or a possible type of allocation you could do, or a variety of allocations, sort of like partitionable, where there's like different options and you can actualize one of them. And I'm kind of wondering if we could eventually get to the place, and I think, first of all, I guess before I go into this, I would say splitting it makes sense. And what I'm talking about here is now in the group mode, can we eventually get to the place where it offers the same functionality without the limitations of the individual mode? And by doing that, we would say like, oh, when you have a pool of CPUs and they're numbered 0 through 1023, or you break that into 4 different groups or something, and then when we apply those constraints, we we pull some out of that, either through some sort of consumable capacity or some sort of counter set, or I know there's some proposals about tying those two together. Like we might be able to model it such that we have a pool and you can say, oh, allocate, CPUs, 8 through 15 to this container, and they kind of come out of that bucket um, of one of the groups and they have certain characteristics, but we don't have to enumerate them all up front. So Kevin had something like this concept of an int range in one of the early prototypes that kind of would help with this too. So anyway, I'm just I'm sort of feeling out the future, but from the my feedback on this is one, I like the idea of having the individual mode, which has a really concrete consumer right now that needs that and doesn't need the other stuff, and keep it simple for them, the external scheduler, Slurm in particular, um, and take the modal complexity out so that like the device classes will be different for each of these drivers, which makes sense because they're consumed so differently from the user point of view. Um, if we have the same driver, it's really weird because based on which mode you run in, you'd have to publish different device classes, and it feels kind of wrong. Like I guess you could just publish them all, but some wouldn't be available in your cluster. Um, so splitting those out and then evolving the grouped mode so that maybe in the long run, it can serve the same use cases as the individual mode, but without the overhead. But that's going to take us a long time to get there. So the split makes sense to me.
Yeah, I just want to answer your question that you asked, John. I mean, so yeah, my answer is I don't know. I think this is possible, but getting there will be quite a long road.
Yeah,
And
great.
and and if anything, that's kind of strengthened my value proposition, which is I'm not the most optimistic fella around, but I think that an individual only DRA CPU driver mode could robustly be GA. It has a fighting chance to be GA by the end of the year. I don't. This is not a promise nor a commit, but I think it's a very real, concrete chance. So mm, I think that there is a value in the proposal. This is why I'm
Yeah,
bringing it
yeah,
up.
I agree. Sotiris?
Yeah, my question is, if I understand correctly the presentation, we it seems that the majority are in favor of having two drivers, correct? So it should be individual driver, CPU, memory,
Uh,
DRA individual driver, and one group driver, correct?
I just want to mention that I don't know if the majority agrees. This is why I'm proposing this idea. I think I didn't run the numbers. I think we have a consensus about having the memory support. This is why I put into the presentation. But about the consensus about the split, no idea. This is why we are talking. But
Okay,
yes,
but
the idea.
the proposal is to have two drivers. So because
Yeah.
I see in the slide continuously we are referring to modes, but actually
Yes.
we want to highlight that we want drivers, to separate drivers.
Yes, the idea is to the
Okay,
CPU driver now has a very fundamental option, which is the individual mode expose each CPU as its own device, and grouped mode, which is create
okay,
basically pool of devices. And yes, the idea will be keep the existing driver as is for individual mode and remove the grouped support and move that in another driver, which will also
mm,
gain the memory support. Now, I want to clarify that it's not that I don't see possible to merge the memory support with the current state, or even in backporting or importing in the individual only, hypothetical individual only driver. But the memory modelization, as I'm aware, really doesn't fit with the individual mode. So exposing each, it is a pool, the memory. So that will be harder, and that further compounds my feeling that okay, you have if we merge the memory feature, that those kind of not work, which the individual mode, which is a very key, option. So, there is a bunch of kind of small smells, to say, that each of them compound, and that makes me create this
Okay.
proposal.
Yeah, thanks for the clarification. So the two other questions that I have is like if in the individual mode, as I understand it, this means that if someone wants to move from individual to group, if it's one driver, it will require a restart, correct, of the driver. It's not like it will be
Yes,
hot plug. Okay.
yes,
Okay. The other question that I have is what about, because I saw the interesting reply, I mean, in the mailing list about the 0.10,
yes,
and there was
yes.
a comment, I think, from the networking group, which I agree that this opens up possibilities if you want to group things together with the NICs and etc. for latency. My question is this, if, I mean, is it the same for this kind of approaches if someone wants to combine different DRA drivers to utilize synergies? Is this something that it is impacted if it's going to be one driver or two separate drivers? I was just wondering if this has been discussed, and is it independent and the DRA will handle it?
My own take is that should be transparent in the sense that both driver could expose attributes that will enable alignment, and I see no real difference in that. But I would also want to mention that I want to highlight something John mentioned earlier, that the device class should be different, because having the same device class for the both modes could really be, I mean, I think it will work if it is about working or not, but it will really kind of awkward to have the same device classes for the different modes. So in that regard, the split doesn't affect too much. It doesn't
Yeah,
make
we
things
should
worse.
we should think about that, Francesco. Like my instinct is to have them separate because they're consumed. The question is like, what's the user's expectations for the behavior of the device class, and is it going to be different based upon the driver mode? I think it probably is. And so, but we should test that theory because the point of like how do you migrate from one to the other, like you can't really migrate running workload because the allocations are different. Like it's already all actualized. So the question is for future, if you were to switch a given node from one driver to the other, like future scheduled things, I don't even know how that would work. Like that's probably a bad idea to try and do that without draining it. So anyway, I think we probably should think about those things. It doesn't change my opinion that this should be different. I'm not sure if that it should be the split, like you're saying. I'm not 100% sure on the different device classes, but that's my instinct that that's probably the right way to go.
Yeah,
Uh, uh,
John, for what you mentioned, I mean, because I see also the other cape that it's ongoing about the CPU hot block, which is a very interesting approach. I was wondering if this management proceeds, which it seems that the Linux supports it, the hardware now, they seem to have found solutions on that.
For
How
the CPU, what? I'm sorry.
that you can have hot plug CPUs
Oh,
with
hot
magic
plug
start in
CPU.
the Linux.
Yeah,
Exactly.
so theoretically, with the DRA driver, it should be simple to do hot plug. Right? You plug in we just publish a new resource slice.
Super. Thanks.
Yeah.
yeah,
Um,
I, I, I see Marlo has her hand raised. Just something super quick before I give her the floor is that it is a very good concern, is a very good point about the migration between the two drivers. But I would just want to mention that the majority of concerns also apply to the different mode, I mean, today.
sure.
It- so yeah, that said, Marlo?
So things like attributes, etc., those would be shared, I think, for both drivers anyways.
Yeah.
So I don't really look at it as different drivers. I look at it as different modes because there's so much shared code. Um, the only difference is how you choose the resource.
Yeah,
Mm,
there's a lot of shared code for sure.
Yeah, and
Express the things differently. I think it's actually less about the code here, the way I'm reading this deck and listening to Francesco, it's partly about the administrative and organizational
Yes.
questions. So like
Yes.
we can declare the individual one GA and it can evolve and get bug fixes and like have a separate release cycle, while the grouped one kind of evolves a little more um, with a little more in dev mode.
Yeah.
Got it.
Yeah.
The other question I have is if you're using this at all for telco, because I know just having them in grouped doesn't always get you the performance you're looking for. Just curious if you're looking at that yet.
We didn't have, I'm not aware of any measure research in that area. I am aware, though, that lack of memory support, which is related but different conversation, is a blocker. That said, the memories merging is not actually a major reason for this proposal. It's more about indeed the different timeline, the different maturity, and the different scope and actually the user experience.
Okay, thank you. I think Pravina has his hand up as well.
Yeah, I think like in general, I agree with this proposal because the use cases are like completely different, and also it would let us like evolve the drivers differently. I agree with what is mentioned here that like the individual mode, at least for the CPU part, is close to being done, while on the group mode there are still a lot more things to like think about. And like about John's earlier point of like, would we have close to the same amount of granularity with the individual mode? There is this one interesting kept that Lionel is driving about like combining, I think, partitionable devices with some form of like consumable capacity concepts like brought into it. I think that would be very interesting because it would let us like derive or consume from a pool and also have like a hierarchy of like pools underneath. So I think that would add a lot of value specifically to the DRA CPU part. One question I had here, like it's mostly specific to the naming thing. So if we split the group mode into DRA driver CPU mem and continue to have DRA driver CPU for specifically the individual mode, maybe this is a question for Marlo, like in future for Slurm or like external scheduler use cases, if we want to do something related to memory or like bring in like memory locality as well, again we would end up in the same position where like we would have to rename things, or yeah, like basically we would have to kind of have the same discussion. So wondering if DRA driver CPU is the right name, or should we even make it like more specific and call out the use case and say that like this is specifically for external scheduler type use cases.
We
Yeah.
don't care as much on memory other than maybe Numa, yeah, Numa positioning. But other than that, I don't think memory is as fragile in positioning.
Okay. So then I guess the consensus is like DRA driver CPU would just be individual mode, and it's better to even call out that it's useful only for external scheduler type use cases, uh, because I don't think it is scalable if we want to like do it
Uh,
yeah, for a general purpose use case.
I for myself, I will
Mhm.
call out the use case as prime use case,
Mhm.
but I want my feeling was not to say, okay, this is for this use case only. This
Mhm.
is the main use case we
Mhm.
know actually, but I won't restrict that. I mean, if some user for some reason they prefer the individual mode, that's perfectly fine, in my opinion.
Okay, I think yeah, makes sense, but it's better to call out the scalability concern that comes along with it, but because I think
Yeah,
like if we exceed
yeah,
a specific number of cores and nodes, I don't think it would work really well with the way
yeah.
like scheduler allocates devices today.
This I agree with. This caveat I agree with.
Yeah,
Okay.
it works best with an external scheduler that doesn't have the same algorithm that Cube Scheduler has, right? Like the algorithm's not and Cube Scheduler is not designed for that level of
Granular, yeah.
of many devices, and Slurm has totally different algorithms.
Okay. Yeah, I think that makes sense.
Okay, I hear and note the concern about code reuse between drivers. I think we can solve it if this is a concern. I think we can surely solve it. So, what this forum think about how the next step will look like? Should I bring this conversation to the wall workgroup device management module to Signode? What's the recommendation?
I mean, I think that Signode technically owns this driver, so um, I don't know that we need this length of discussion in Signode, but probably it should at least be a bullet point in a 5-minute conversation of, hey, this is the consensus. I don't think we need to go to the larger working group because this is kind of a specific subset of the working group that cares about this. I would just say, I mean, it doesn't hurt to if there's time, but I would suggest probably Signode and just say, this is our current plan. When if there's
concern or objections, or I agree, makes sense. Yes. Okay. I depending on the agenda, I will try to present today in few, or if not, I would like to get the pulse next week. Why to waste?
I won't be there at Signode today, but that's fine. Doesn't matter whether I'm there or not.
Yeah. Yeah. Okay, let's see. Thank you, everyone, for the feedback. If there are other questions or concerns, hit me.
Looks like we have one. Satiris has a hand again, so.
Yeah, I think my question is coming from using CPU Manager very heavily in my work. And as you know, we are like trying to have this in-place pod vertical scaling alongside CPU Manager. My question is for the DRA CPU driver, has this been discussed? Is it planned? Is it possible?
So in-place vertical pod scaling. So in-place updates for pods currently only supports CPU and memory, I believe. We've we currently have not made any specific efforts to extend that to resource claims. So the strategy there would be, there's two strategies we can do for in-place pod updates for DRA. One is mutability of resource claims. The other is mutability of the claims list in the pod spec. I think the latter one is going to be the easier one to implement. Mutability of the resource claim is pretty tricky. But being able to add a claim or remove a claim from a pod may be less tricky, but it's still going to require basically the biggest issue probably is it probably requires plumbing all the way down from the kubelet to the DRA driver to the container runtime.
Correct.
And so no, the short answer is everything I just said in the last 30 seconds is about the extent of the thought that we put into this.
Okay, but I understand if it is hard. I mean, my experience with the CPU Manager, I share but we have to understand that one reason that we use Kubernetes is the cloud native and get all these benefits. And a lot of the features, at least when you have the use of exclusive CPUs, at least in the telco, it is blocking of not utilizing it.
So I would love if somebody has the time and energy and to start that conversation in Signode. That's going to be a conversation in Signode. Like, hey, can we add in-place pod resize for adding and removing resource claims? One of the challenges today, in-place pod resize is done locally on the node. Wow.
Yeah, I'm not saying to solve it now, but from what I'm listening, it's something that you haven't found that we can hit a wall. Besides that, it might take effort.
Yeah,
there is not something that blocks us.
Yeah.
Okay, that's sure. I mean, okay, then that's great. Okay.
It's just a lot of work, but yeah, I'd love it. Yeah, it'd be great.
Yeah, I think from my point of view, I'm speaking like Sotiris. I mean, always the feature parity is important when you have something else coming, which has the benefits. So I see it from this perspective. But I'm glad that there is not something blocking that. Besides that, it will be a long journey, but I think it's possible. Thanks, John.
Sure. Yeah. Okay. Any other topics or questions?
Since we have some time, I just added one topic. So I don't know if I have access to share my
I
screen.
can give that to you. Just a second. All right.
Yeah, I think like this is a topic that like Gaurav raised in the last working group meeting about us running into race conditions when container runtime restarts. So basically, like the concern that Gaurav raised is like now that we are using DRA and NRI in combination to like in DRA net or CPU DRA driver to like allocate devices to containers. The problem that he noticed was like when container runtime is restarting, so and we are also creating a pod, we could end up in a situation where like a pod, if when the pod is getting created, if the NRI plugin is like not running at the time, we could have the pod like start without the NRI hooks that is required by the DRA CPU driver or DRA net run. I think like this, there are two problems here, like two use cases here. One is for use cases where DRA for like DRA net, where we only need the NRI plugin for pods that request these resources. So basically, only for pods with claims. The use case with CPU DRA driver is a little different in that, like, one, we need the NRI plugin to run for pods with resource claims to allocate it like exclusive CPUs, but we also need the NRI plugin to run for other pods or containers which does not have like any resource claims. And this is mostly to exclude the exclusive CPUs out of the CPU pool, CPU allocation for other containers. So some of the proposals that are being discussed on this issue is like basically annotating the pod so that like the pod fails to start if the NRI plugin is not running. And this proposal only works for DRA net use cases. And I think for CPU DRA driver, what was discussed here, or rather like suggested here, is like we would need something like a you need to configure it as like a global NRI, or I don't know the right terminology. So basically, like configure it as like a global plugin so that like any container would fail to start if this plugin is not running. So mostly wanted to bring this here and get people's feedback on like uh yeah, like if this is the right direction, or if there are like any other alternatives that we could consider to solve this problem.
I posted a comment there in this issue with all the options that we discussed.
Mhm.
Yeah, you may find it. So I think one question for me is, NRI already support global required plugins through configuration, but to do that, you need to update configuration, and I think you also need to restart containerd. I was wondering if, and I posted suggestions that maybe we need to do we need to allow daemon sets to configure themselves as global plugin, maybe with some timeout. So like when I'm registering, I'm saying like, even if I'm not around for next hour, make me required, like wait for me. Like maybe I'm restarting, maybe something happening with me, but like for the next hour, I will be required plugin no matter whether I'm running or not. And this will solve some of the problems. And I'm thinking whether we like how hard we need to push on containerd and NRI to implement this feature. it really depends on how much we believe in like the CDI, like CPU DRA plugin will be installed once in the entire cluster and forget about it. So we can update configuration and do like just leave with that. Or it will be more dynamic, like people will create clusters, like subset of nodes will be managed by this CPU DRA driver. Sometimes you change the subset of nodes and you need to unregister yourself. So that's like, depending on how dynamic we see CPU DRA driver will be, we need to like decide how hard we need to push on containerd and CRI-O to support this functionality.
I think that we don't know the answer to that question. You're right. We need to see if we can figure out how to get an answer to that question. But my instinct is that, I mean, once a node is provisioned, it's going to stick with whatever you pick, right? It's not like an individual node's going to use one method and then a different method and then a different method. So you might have groups of nodes that use it, but it'd be like this whole node pool, right? And then it's for its whole life. That's my instinct. Whether it's valid or not, I can't say. So I think the question was around, yeah, at that point, you just globally configure it to say for this node, not globally, but for this global in the sense of global for the node, for this instantiation of the runtime, these NRI plugins are expected and required. The question is like in your node provisioning process, if it's done via daemon set, if your CPU driver is deployed via a daemon set,
I mean, we've been solving this problem for a while. Like GPU driver needs to be installed, right? So GPU driver needs to be installed so your GPU DRA plugin works.
Right.
So it's not a new problem.
Right, exactly. Yeah. It's node set. Yeah. It gets back to just basic node setup downstream problems, right? Like,
yeah. But do you think that DRA net is different enough that they don't want them to be global for a node and instead to have some backward solution? Like how DRA net is different in this sense?
It's not global for a node, shouldn't it be?
So I can speak for that, Sergey. First of all, thanks a lot for the feedback that you've been giving on both the PR and the doc. That's really appreciated. So I believe that the main difference between CPU and DRA net was that, like Praveen said, for CPU, we have a case where we want to make some change or at least perform some validation, even for the pods where we are not using DRA. That is the primary thing, right? Even if a pod is not using DRA at all, we want to perform some validation or something with the CPU DRA driver. But with DRA net, that is not the case. If a pod is not using DRA, like we just completely want to ignore it altogether. There is no need for us to inspect that pod in any way, which means like we don't have a requirement of being globally required.
Right, but you could just look at it and go, oh, this pod doesn't, I don't care about this pod, and just return, right? Like that might just simplify everything.
That will simplify things, but the problem that I have over there is like, then it introduces DRNet as well onto the critical path of any pod that gets scheduled on the node. And I don't want to become that failure point, because just for the sake that, okay, we don't have a better option. For CPU DRA driver, we have a valid use case where we want to inspect all pods. But in this case, like we don't actually have a use case where we want to inspect all pods. So getting into the critical part just because there's no better option doesn't feel like the right thing.
Yeah, it feels like a short-term workaround as opposed to a permanent solution.
It doesn't, like, in general, in Kubernetes, it is always like that. So like there is not really good filtering mechanism. When you schedule something on a node and something doesn't work for some other functionality, like containerd doesn't work, it will not work for you as well. So there is no good filtering. Somebody sharing the emails. Yeah. Whoever shares the screen shares the email.
Yeah. Sorry, you were saying, yeah, everything kind of works that way already. So it's not like a
it's not a new problem. Like difference here is that the seemingly has a beautiful solution through annotations, and like even like if only DRA net will provide these annotations, and the annotation will be provided back to an NRI plugin, then it will all work magically. But for me, it creates this like small bubble of special casing of DRA net, and like if your NRI plugin doesn't have DRA requirement, like why it have it worse than DRA net? Like why it will need to become a global requirement for everything if it doesn't have DRA support? So like, would we like, let's say I only want to have a writable C groups when there is specific annotation on a pod, and I'm creating writable C group NRI plugin as a requirement for every single pod. Like, why wouldn't I want the filtering for this writable C group NRI plugin? And why this filtering should be on a level of DRA propagating these attributes rather than on NRI infrastructure supporting this kind of filtering for you. Maybe you register yourself as a required with specific cell attributes, and like if there are cell attributes satisfied, then you will be used as a required, and if cell attributes are not satisfied, you are not used as a required. So maybe this needs to be implemented rather than trying to special cases DRA to NRI information propagation.
You're saying add the filter at the container D, or well, the NRI configuration where you can say it's required. You could say it's required under these conditions.
So, Sergey, I'm not looking at this as special casing things for NRI, but I'm rather looking at these things as DRA already understands CDI as a native mechanism, right? And NRI is just an alternative to using CDI. Perhaps, sure, you can use both CDI and NRI together. But just the fact that DRA does understand what CDI means makes me think that DRA could also at least make an attempt at understanding what NRI means. And when I say what CDI means, I'm just referring to the fact that DRA gets CDI devices in response from the DRA driver, and then it passes along to the container runtimes. So in a similar manner, I assume we should be able to say the same thing with NRI plugins, that it gets some information back, something like maybe NRI devices or NRI annotations, and then it passes it along to the container runtime. The other point, okay, first, sorry, I don't want to hijack this meeting with this discussion because I was hoping to perhaps have this discussion in the other meeting. So I think, Satoris, you have your hand raised, and if we have perhaps other topics, we could take those up. But yeah, I'll stop.
So actually, I had a question to your comment. I mean, from your perspective, since you have this differentiation between the CPU driver and the net DRA, I was wondering from a security perspective, and has this been investigated? Because if you have something that doesn't take all, then perhaps it is open for a malicious attack. I mean, I'm just asking out loud because how has this been discussed from this perspective?
I'm sorry, I didn't fully understand the security aspect. Can you phrase it in a different manner, or if someone else can help me understand?
Yeah, I mean, you said that, if I understand correctly, that in the one approach, you don't want to check all the pods, only the ones that is being used. And then I'm just thinking out loud, if you do this, then you are open to a security issue that someone is using the hardware outside and might impact the pods. And it cannot be visible to the main entity that controls everything because this pod is never there. So perhaps already this has been...
Oh, you're saying somebody uses...
Correct, bypasses.
A couple weeks ago that I read this, but I think that the plan wasn't for the user to annotate the pod. The plan was that the driver would somehow communicate that, would decorate the something, but in the prepare call or something. I don't remember.
Yeah, I think that's right. That, if I understand Gaurav's proposal, I think the driver would add these annotations in the CDI file, and
Right.
that
So
is propagated to NRI.
so what that means, Harris, is that anything that's using that the DRA scheduler has allocated a DRA net device for, the DRA net driver would see it and it would be able to say, yes, the DRA net NRI plugin should look at this. Anything that wasn't using a DRA net device wouldn't go through that path. And so there's not really a security issue in the sense that like somebody could use one of those devices without DRA net knowing, because the only way they could do that is the way they could do it today, which is run a privileged pod, which is can just go on the host and find the in hostnet or something and find the interfaces. Like, but generally, there's nothing we can do about that once you're root, whatever, we're done. So there is I think a security question about like any old daemon set coming and registering NRI plugins, but again, that's probably managed by Unix permissions on the containerd config or socket or something. So I don't think there's a security issue, but there is a question of like landing in the critical path. So if you're down or you're upgrading, other pods that don't even use you don't start, which is kind of annoying to them. I don't know. Like, sounds like there's more discussion needed on all of this, and that's fine. You can bring it again to. I think we talked about it at the work group meeting once before, right? But now the discussion's evolved.
Yeah, so we talked about it last time very briefly, and since then I have at least drafted up some documentation where we can all collect our thoughts. And I think I'll bring this up again in the next meeting. I think I was hoping on bringing this up in the last meeting, but it seems like there were no maintainers actually in the last meeting. I think everyone was out of office, so well, next meeting it is.
Okay. The other, I mean, I think that at the very least, like whatever the specific details of the solution are, like the CDI plus NRI, DRA plugins that use both are clearly a pattern we've got, and so we should try and determine what the requirements are to make that work as best we can. So totally makes sense.
We already have requirements that are very different. In one case you need to filter, in another case you need to globally apply.
Right.
So yeah, it's already two different requirements. And I'm in a list I posted in the issue. I don't see those solutions that mutually excluding. Like, just my point is, if it solves a global problem, like easy global registration, then it solves majority of use cases, and there are edge cases like reliability problems. But there's like, for me, it feels like DRAnet has an easy out through kubelet, but there are so many other NRI plugins that we will need to solve the same exact problem in future. So like, I would rather concentrate on that rather than spreading out this effort across multiple work streams. And like,
well, one thing one of the things ways Sergey helps keep us honest is like always asking like, okay, like, can we get some experience with it before we make a more complicated solution? So I kind of like that, right? Like, if we start with the global one and we have reliability issues, or we in parallel, we work to say, okay, we're going to take this out of the reliability path. We may find that it's so rare that it's not worth the effort. But okay, well, we can keep talking, but we're getting close to the end. So
I think like just to if I summarize my understanding for like the DRA driver use case, do we think that like we can use the globally required method to make sure like the plugin is always running? So that seems like a good path forward.
Yeah. Okay. What we need though is like what we talked about. Like, it's not really an upstream. It's not traditionally not been an upstream concern, but there's a downstream, like, how do you provision a node concern, and configure the things based on what you expect to run on that node.
Okay, I'll look more into the details of it. Yeah, thank you.
You're familiar with all the stuff like AJ is doing with the node readiness, like all that kind of
stuff. Yeah.
Okay.
Thank you.
Thank you, everybody, and we'll see you soon. Bye.
Thank you.
Thank
Bye.
you, John.
Thank you.
Bye.
See you.